Hello, Algebra 2, and welcome to another edition of our video notes. Today we're looking at 7.5 exponential and logarithmic equations, day 1. Just one note on delta math. There will be some problems that have exponential equations with base e, or on the next lesson, day 2, logarithms that have natural logs, you can skip those. So just hit skip. There will be no penalty for skipping those, so you can go ahead and do that. In section 6, we'll be looking at those types of equations that have base e or a natural log. So first, our new concept, an exponential equation is an equation that contains the form a equals a base of a exponent to a base of a power to some exponent where your exponent has a variable. And when we're going to be able to use properties of logs to solve for that exponent. So I'm going to abbreviate exponent has a variable. So anytime we have an unknown exponent, we can use the properties of logs that we discussed a little bit yesterday, or any other strategies we've been talking about so far with exponents to help us solve out our problems. So let's go ahead and take a look at problem 1. So problem 1, we have a base of 256 to a power of 2x. So there's our variable up in the exponent is equal to 64. If you notice that you have two powers that are two numbers that have a common base, you can solve these using that common base. So I'm looking at my power sheet, and if I look at row 4 has a 64 and a 256. And I can also look at row 2. Row 2 also has a 64 and a 256. So I could use either of those bases, base of 2 or base of 4, to solve this out. Like if I used a base of 2, the 256 I could rewrite as 2 to the 8th power. And then the 64 I could rewrite as 2 to the 6th power. So instead of 256 to the 2x, I'm going to have 2 to the 8th to the 2x, and then 64 I could rewrite as 2 to the 6th power. Now I've got this common base of 2, and up here I have this power to a power, so I'm going to have 16x. So 2 to the 16x is going to equal 2 to the 6. And since they have a common base, I'm now just comparing their exponents. So I'm going to have 16x is equal to 6. Then I have to divide both sides by 16. I'm going to get x is equal to 6/16. Or we'll simplify that down. That's going to be 3/8. So 3/8 is our missing value. So if we have that common base, if you can see that, you can check your power sheet, just kind of checking your two numbers. You can use that common base to start to write your exponents with the same base and then just compare your exponents. Just a note on this one, if I wanted to use the base of 4, I could do 4 to the 4th, which is also equivalent to 256, and then 4 to the 3rd, which is also equivalent to 64. I'd still get the same answer. Let's head down. We'll look at problem 2. So problem 2, we're checking out the bases, and I've got a base of 6 and a base of 512. So I check my power sheet. So base of 6 would be in row 6. And that has a 36, 216, 1296. So I do not have the 512 in that row. So 6 and 512 I cannot write as a common base. Well, here's where we have to use a logarithm to solve this problem. So yesterday we looked at this property of logarithms. If you have a log with a base of b, so any base, and then you have a exponent or a power in where the number is, you can rewrite that as this exponent out in front, n log base of b to the m. So this exponent n can always be rewritten down in front of our log, and now it's more accessible. So when it's up in that exponent, that variable 4x is up in our exponent. Can't really use it up there, but if we can start to get this log form going, then we can start to rewrite that n out in front of our problem. So way back when you started pre-algebra, you talked about balancing your equation. Well, as long as we do the same thing to both sides of our equation is going to stay exactly balanced. So for this problem, anytime I don't have a common base between my two powers, I'm going to do what's called logging both sides. So I'm going to log the left side, which is log 6 to the 4x. And then I'm going to log the right side, which is now log 512. And we're logging both sides. We're doing the same thing on both sides of our equation, which is not going to change its equality. And I'm just going to use log base 10 because that's a quick shortcut button that I can use on my calculator. So here's where the magic happens. Now we got this 4x right here. That 4x I can drop down in front. So I'm going to have 4x times the log of 6 is equal to the log of 512. Now lastly, we've got this x now accessible. So here this is representing 4 times x times log of 6. So I got all multiplication happening. To get to my variable, then I'm going to undo those two multiplications. I'm going to divide by 4 log 6. Then over here, I'm going to divide by 4 log 6. So to solve this one, we're going to need to take the log of 512 and then divide it by 4 times log of 6. So we're going to head to our calculator now and get that one solved out. So back to our calculator. So when you're logging both sides, it's a great idea just to always use this common log because that's an easy button to use on your calculator. So I'm going to go log of 512 divided by, now I'm dividing by 4 times the log of 6. So I'm going to group that together. So I'm going to open up a set of parentheses. So the denominator, or what I'm dividing by, I'm going to have 4 times log of 6. I'm going to close off the parentheses for the log. And then I'm also going to close off the parentheses I opened right there. So now I got the log of 512 divided by 4 times the log of 6. And this will now solve for that x. And I should get about 0.8704. And if you look at your delta math, they're going to say round to the nearest hundredth. So we'll round that off to the nearest hundredth. That would be 2 decimal places. So 0.87 would be a good estimate about what our x needs to be for that power to work. So that would be our answer for example 2. All right, let's head back then. We'll look at example 3. So what is the solution of 5 to the 2x equals 3,500? So we'll start by logging both sides. And as you start to get this step down, you'll be able to kind of streamline this. We could just put that 2x out in front right away. So log 5 2x equals log of 200. I'm just going to make that an O. So that's log of 3,500. Then I'll drop that 2x out in front. So we'll have 2x times the log of 5 equals the log of 3,500. And then we'll divide by 2 log 5. So both sides get divided by 2 log 5. And we'll head back to our calculator to see what we'd get. So head back to here. And we'll now go log of 3,500. Close off that parentheses because that's going to be your whole numerator. Then divide, open up a set of parentheses, 2 log of 5. And then I close off the parentheses for the log and then close off the parentheses for the whole denominator. Hit enter and we should get about 2.535, which if we're rounding to the nearest hundredth, that's going to be 2.5. And then I look at the 3, the next number is a 5, so that's going to round up. That would be 2.54. So there would be our answer for example 3. Now lastly, heading to 1 delta math problem. So we will see a little bit of a variation of these exponentials. So like looking at this first problem, I've got a 6 times 10 to the x. Well, I don't have my exponent needs to be isolated first. So I'm going to divide both sides by 6. So then I'm going to rewrite that problem as 10 to the x equals 1/6. Now I'd be ready to log both sides. So log of 10x is going to equal the log of 1/6. And now I can divide log of 6 by log of 10, log of 1/6. So I divide both sides by the log of 10. So I'm going to type in my calculator. I'm just going to do this on my handheld. I got log of 1/6 divided by the log of 10. And we get our answer, which is negative 0.778. So we'll put in negative 0.778. So the second 7 will be rounded to an 8 because of that 8. So it'll be negative 0.78. So that'll be our answer for that problem. If we have any other extra numbers around our power part, we're going to want to do algebra to get that all isolated. Then we'll be ready to log both sides. And once we log both sides, we're using that property from yesterday to get our exponent available and able to solve for it. And that's how we can start to solve these exponential equations. So you're ready to look at 7.5 day 1. Remember, if you're seeing any natural log, those are LNs or E's. You can skip over those. There'll be no penalty. But you're ready to go for day 1, and you can go ahead and good luck, and we'll see you next time.